Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question second, part A says, by referring to both kinetic energy and potential energy, explain what is meant by the internal energy of an ideal gas. So first of all, let's try to understand internal energy in a very simple language. So we can say internal energy. Internal energy is the sum of kinetic energies plus potential energies of all the molecules, is the sum of all the random and microscopic kinetic energies and potential energies of all the molecules in a gas. So that is internal energy of a gas. Now how we can define internal energy for an ideal gas? For ideal gases, we need to understand there are no intermolecular forces, no attractive forces between molecules. It means that potential energy of ideal gases is equal to 0. So it simply means that internal energy of ideal gas is equal to sum of random kinetic energies of all the molecules in a gas. So these are the points we need to understand. Now let me show you the answer, how you can write down a proper answer. We need to understand all molecules in a gas, they do not have same kinetic energy or same potential energy. Kinetic energy and potential energy, they are randomly distributed. Some have higher kinetic energy, some have lower kinetic energy. So this point is very important, we need to understand. And these points we have to mention in the answer. Now let me show you how you can write on the answer. In the answer you have to mention these points. First of all, we have mentioned it is the sum of all the random and microscopic potential energy and kinetic energy. If this object is moving, it has two kind of kinetic energy. One is the external kinetic energy, mean whole system is moving, whole pen is moving, that is the external. And one is the internal, due to internal kinetic energy it has temperature. So these are two different kinetic energies. So we have to talk about random and microscopic kinetic energy. Microscopic is very important one. For an ideal gas, potential energy is 0. This point you also need to mention. Part B says a fixed mass of an ideal gas at a temperature of 20 degrees Celsius is sealed in a cylinder by a piston as shown in the figure. The initial volume of the gas is 1.24 times 10 to minus 4 meters cube. Thermal energy is supplied to the gas and its volume increases by, very important one, understanding of question is very important. Increases by, it means this is delta V. So delta V in this case is given to us, that is equal to 5.20 times 10 to minus 5 meter cube. The piston is freely moving so that the gas is always at atmospheric pressure. And atmospheric pressure is given to us. We need to calculate work done by the gas. So work done by the gas, simply work done by gas, this is equal to P times delta V. As in this case, it is expanding. So work done by gas is positive. Simply you can use this formula. You can say P times V final minus V initial. If you have the values, if work done by gas is positive, you will get positive result. If you get negative result, it means work done by gas is negative. But when gas is expanding, work done by gas is positive. So for this question, we have value of P, that is 1.01 times 10 to 5. And change in volume we have, that is 5.20 times 10 to minus 5 meter cube. And if we solve this one, we will get 5.25 joules. And this is positive because gas is expanding. And also this formula is only used if P is constant. So P has to be constant. So they can ask you this question in different ways. So this formula is only valid if P is constant when the gas is expanding or when the gas is compressed. So the answer for this question is 5.25. Second part says calculate the final thermodynamic temperature of the gas. Means answer has to be in kelvins. Thermodynamic temperature means absolute temperature. So how we can answer this question? We can simply start from very basic. For an ideal gas, the ratio between P1 V1 over T1, this should be equal to P2 V2 over T2. But in this case, P1 is equal to P2 because P is constant. So simply then we can say, in this case, V1 over T1, this is equal to V2 over T2. And for this question, we need to find out value of T2. So we can rearrange, we can write down T2. This one has to be equal to V2 times T1 divided by V1. And value of V2, let me explain you here. Value of V2, this has to be equal to V1 plus increase in volume. Value of V1 we have that was equal to 1.24, and the increase in volume we have that was equal to 0.520. Actually this is multiplied by 10 to minus 4. So it simply means that V2 we have that is equal to 1.24 plus 0.520, and this is multiplied by 10 to minus 4. And here we have value of T1. Value of T1 we can also find out. Value of T1 was 20 degrees Celsius, so in Kelvin this has to be equal to plus 273. So it means that this will be 293. So we can also write down here this is 293 divided by V1. V1 is 1.24 times 10 to minus 4. So simply 10 to minus 4 we can cancel and we can simplify. So if we simplify, the value of T2 will be equal to 416 Kelvin up to 3 SF. So this is our final answer. So main concept is this one. This one is the main concept. Sometimes in the exam they will ask you to prove is this process obey ideal gas laws or not. And so simply you can start with this equation, you can plug in values. If result is the same, means two sides of equation, if they are equal, it means it obeys ideal gas law, otherwise not. So this is also a very common question in past papers. So physics is about understanding. Physics is different than chemistry, different than bio. In physics, you no need to memorize a lot of things. You need to understand how to apply. Later I will also upload one video how to solve physics problem. I will explain these things in detail. Question says the mass of the gas is 16 grams. For this expansion there is a net transfer of 960 joules of thermal energy to the gas. Calculate the specific heat capacity of the gas at this pressure. So simply we need to calculate specific heat capacity of the gas. We can also understand this one in a better way so you can visualize. So in this case we have gas, mass of the gas is 16 grams, and temperature of the gas we have delta T. Temperature of the gas rises from 293 to 416 Kelvin, and mass of the gas we have, and value of Q we have. So in this case we can also write down here the amount of thermal energy supplied to this gas Q, that is equal to 960 joules. So in this way you can visualize, not just look at the formula, use the formula and find the answer. So you can visualize what is happening. So simply now we can write down Q is equal to MC delta T. We need to find out value of C, so that will be equal to Q divided by M times delta T. Value of Q is 960 joules and the mass is 16 grams. It means 16 times 10 to minus 3. We have to use SI units, and the change in temperature we have, that is 200, 416. Temperature rises in this case, that is 416 minus 293 Kelvin. This has to be in Kelvin because here the unit is Kelvin. Now if we simplify this one, we will get 490 joules per kg per Kelvin. So this is how we need to answer. So the answer for this question is 490 joules per kg per Kelvin. Part C says the gas in B is allowed to return to its starting temperature. The piston is now fixed in position. Thermal energy is supplied to increase the temperature to the same final temperature as in B. Use the first law of thermodynamics to suggest and explain how the specific heat capacity of the gas for this situation compares with the value in P theory. So in the last part, pressure was constant, but in this case volume is constant, and value of C depends on pressure and also depends on volume. If pressure is constant, value of C will be different, and if volume is constant, value of C will be different. So we call CP and CV. We call CP value of C as constant pressure and value of C at constant volume. So these two values are different. So how we can answer this question? So first of all, in this case we can simply sketch. So this is cylinder, and here we have piston. So this is the piston. Now this piston is fixed. So piston is fixed, it means volume is fixed. And in this case delta T is the same. Delta T is same, so we can say delta T. If delta T is the same for an ideal gas, delta U is also the same. As in this case there is no change in volume, delta V is equal to 0. So it means that work done is equal to 0. So we can use first law of thermodynamics now. Simply we can say delta U, this has to be equal to Q plus W. So in this case delta U has to be equal to Q because work done is equal to 0. And in the last case, so this is the new situation now. In the last case we have delta U that was equal to Q plus W. So we can say this one is Q1 and this one we can say this is Q2. So this is Q2. In this case gas is expanding. Very important point, gas is expanding. As gas is expanding, it means work done by gas is positive, but work done on gas is negative. So it means that delta U, this is equal to Q1 minus W. So from here we can say Q1 will be equal to delta U plus W. You need to understand this is work done on gas, very important one. So in this case delta U is, in this case Q1 is equal to delta U plus W. So we can simply say Q1 is greater than Q2. So this is the conclusion from these two processes. So this is the conclusion. This is at constant volume. So this is at constant volume. And this one is taking place at constant pressure. So we can say this is constant pressure. So it means Q1 is greater than Q2. Now we can write down C. C is equal to Q over M times delta T. As in this case, M is the same, rise in temperature is the same. So if Q go down, it means C will go down. So it means in order to raise same temperature, we need to supply lower amount of thermal energy. So new value of C in this case will be lower because Q needed is lower. I hope this makes sense. Now let's try to write down the answer. In the answer we can mention these points. So this is what we have to mention in the answer. So simply we can say same temperature, so it means that same change in internal energy as we have mentioned here. So this point we have mentioned here, same temperature change, same change in internal energy, as no change in volume, work done is equal to 0. No change in volume, work done is equal to 0. By first law of thermodynamics, less thermal energy is needed, so Q2 is lower than Q1, so new value of C is smaller than the previous value. Question 3 says a small object of mass 24 grams rests on a platform. The platform is attached to an oscillator as shown in figure 3.1. The oscillator moves the platform up and down. The total energy of the oscillation of the object is 2.2 times 10 to minus 4 joules. In one oscillation, the object travels a total distance of 14 millimeters. Calculate angular frequency of the oscillations. So first of all, we need to understand the total energy is given. So we can say this is E total, and this is the total distance for one complete oscillation. So it simply means that, let's say object started from equilibrium, it goes to the highest position, so the distance travel is equal to 1 amplitude. Then it come back to equilibrium, it again travel distance equal to 1 amplitude. Then it go down to lowest position, so this distance is also equal to 1 amplitude. Then it come back to equilibrium again. So from here we can say d total, this is equal to 4 times of amplitude, and total distance we have, that is equal to 14 millimeters, means 14 times 10 to minus 3 meters. So we can say amplitude is equal to 14 times 10 to minus 3 divided by 4. So here the unit is meter. Total energy, so the total energy can be equal to, so E total, this can be equal to kinetic energy maximum, so we can say KE maximum. This also can be equal to potential energy maximum, but we can use kinetic energy here, so this is easy. We can say this will be equal to 1/2 m V max square, so we can say V max square. So we can say this is 1/2, here we have m, and V max we need to understand, V max is equal to A times omega. So simply we can replace V max with A omega, so we will get A square omega square. Now simply we need to plug in values. Total energy we have, so we can simply first write down here, this is E total, so we can rewrite once, and now we can plug in values. E total is 2.2 times 10 to minus 4 joules. Here we have 1/2, and the mass is 24 grams. So 24 times 10 to minus 3, so this is in kgs, and amplitude we have, that is 14 times 10 to minus 3 divided by 4 square, and multiply by omega square. So here we have omega square, so we can solve for omega square now, and we will get value of omega. So omega in this case will be equal to 39 radians per second up to 2 SF. So this is the final answer. So the main concept is this one. You need to understand, in one oscillation total distance is equal to 4 times of amplitude. You also need to understand total energy is equal to this. Rest is simply plug in numbers and find the answer. Part B says the frequency of the oscillator is fixed and the amplitude of the oscillations is gradually increased. Calculate the maximum amplitude of the oscillation so the object does not lose contact with the platform. So in order to answer this question, we need to understand there are two kinds of accelerations. One is acceleration due to gravity, that is the maximum acceleration of this object, mean maximum downward acceleration of this object is equal to g. But if the acceleration of oscillator downward increase, mean is greater than g, so it means object will lose contact with oscillator. So this is what will happen, like this. So this is the main concept. So we can say as long as acceleration of oscillator is less than R equal to G, object is in contact with oscillator. So this one we can say in contact. And if acceleration of oscillator, this is greater than G, it will lose contact, mean object will lose contact with oscillator. So this is the main concept. Now how we can calculate the maximum amplitude? So simply we can say A, this is equal to minus omega square x. Omega square x. A in this case will be equal to G, the maximum value of acceleration. So this is equal to minus omega square. We can say this one is A. We need to find out value of A, so we will get in this case value of G. This is divided by minus omega square. So we are only interested in magnitude, so simply we can say this is divided by omega square. So value of G is 9.81, and omega value we have calculated, that was 39 square. 39 square because square is here. Now if we solve this one, we will get in this case 6.4 times 10 to minus 3. So this is value of maximum amplitude, and this is how we can figure out. So this is our final answer. So this is the main concept. If this concept is clear to you, then simply you have to use this equation and you can find the answer. Second part says the amplitude of the oscillation is increased, so it is greater than the value in B1. State and explain the position in an oscillation where the object first loses contact with the platform. As we discussed before, the maximum downward acceleration of the object is equal to G. Maximum downward acceleration of this object is equal to G. And when acceleration of oscillator, means the downward acceleration of oscillator, is greater than G, it will lose contact. And where this will happen? This will happen at the top of oscillations, not at the bottom. At the bottom, if acceleration is greater than G, it will still stay in contact, and it will lose contact when acceleration of oscillator is greater than G at the top. Mean oscillator will fall down faster than the object, so it will lose contact at the top when the acceleration of oscillator, downward acceleration of oscillator, is greater than G. So these 2 points we have to mention to get full marks, mean to get 2 marks. So 1 point we can say this will happen at the top of oscillation, so you will get 1 mark, where the downward acceleration of oscillator first exceeds the free fall acceleration at the top and downward. So as we mentioned before, it will lose contact when acceleration of oscillator is greater than G, and this is downward acceleration. So we are talking about here downwards acceleration of oscillator. So this is how we need to answer, and this will happen at top of oscillations, at top of oscillations. Here. I hope this question makes sense. If these videos are helping you to improve your understanding of physics, please like and subscribe, because your encouragement is very important. And if you're looking for more resources, you can join Patreon. On Patreon, you will see full video solutions of past papers, and also notes and much more than that. See you next video.